Now problem 3 asks us to find f composite g, g composite f, and then finally evaluate f composite g of 1. So over here far left, I'm going to calculate f composite g. Now it's going to help to know by definition that is f of g of x. So the rule is what you're supposed to do is write down the first function listed. No matter which form it's in, notice the f is listed first. So I'll write the f function down with parentheses everywhere there's an x. So see, there's my x. When I'm looking at the f function, that's going to equal to parentheses minus 2. Now what goes in those sets of parentheses is the inside function, either the second listed function, well it is the second listed function no matter what. G of x is x squared plus 1, so that goes inside the parentheses. Then after that, you're just charged with simplifying it. So you have x squared plus 1 minus 2. I've got like terms right here. I can combine x squared minus 1, and we're finished with f composite g of x. Now let's move on to g composite f. So g composite f of x is g of f of x. No matter what, you're supposed to write the first function listed down first, remove all of the x values, and replace it with parentheses. So there's my x in my g function, so I'm going to have parentheses squared plus 1. So notice I remove the x, I put parentheses there instead. The square is on the outside of the parentheses plus 1. Now what goes inside those parentheses? The second function listed, your f of x function, which is x minus 2. Now this problem has a little bit more work. Why? Because you have to square that x minus 2. So I'm going to do x minus 2 times x minus 2 squared plus 1. Not squared, we handled the square, I'm sorry, when I wrote it out twice. I've got to FOIL. So x times x is x squared, x times negative 2 is negative 2x. Then I can go underneath and continue that. Negative 2 times x is negative 2x. Negative 2 times negative 2 is plus 4, plus 1. Then I combine like terms. So I have x squared minus 4x plus 5. So that is g composite f of x. And then finally part C asks for f composite g of 1. So f composite g of 1 by definition is equal to f of g of 1. Now what we can do here, instead of writing the functions down, how about we just evaluate the inside first? When there's an x in there, we can't do that. But when there's a 1 in there, we can. So that's going to be f of, now what's g of 1? Plug 1 into the g function. That'd be 1 squared plus 1. So I went over here and I looked at the g function. I removed the x and I put a 1 there instead. So that's going to give me f of 1 squared is 1 plus 1 is 2. Now this asks me to go to the f function and plug 2 in. So when I look at the f function, it is x minus 2. So I'm going to say that's equal to 2 minus 2, which gives me 0. Problem 4 asks us to find f composite g, g composite f, and then f composite g of 2. Alright, so for part A, f composite g, by definition of x, is f of g of x. So what that's asking me to do is write the f function down first. So here's the f function, but I'm going to remove the x and put parentheses there instead. So that's the square root of parentheses plus 4. Now what goes in the parentheses is my inside function. It's the g of x, what's written second. And so I write that entire thing, that entire function, which is x squared, in every set of parentheses that shows up. In this case, that's it. And then I simplify my expression if possible. But you know what? The square root of x squared plus 4, that's as simple as that gets. I can't say that's x plus 2. Square roots don't work that way. You can't take the square root of each of something you're adding together. You just have to leave it just like that. Now, let's work backwards. I'm supposed to find g composite f of x for part B. So let's do that in green. So g composite f of x, by definition, is g of f of x. So what am I supposed to do? I'm supposed to write the g function down, okay, x squared, and put parentheses everywhere there's an x. Well, if it's just x squared, that's going to be parentheses squared. What goes inside? The second function listed, which is the f function, the whole thing. So that's going to be the square root of x plus 4 that fits in those parentheses. Now, if you have an expression that will simplify, you should, and y'all, this time we do, because this square root goes all the way across the x plus 4. That means this square root and this square cancel each other out to give you x plus 4. Now, again, this square root and this square do not cancel each other out because this square does not apply to the whole expression underneath. It only applies to the x squared, and you're not allowed to take the square root of a sum of each part. It doesn't work that way. All right, and then for the last problem, we have f composite g of 2. So f composite g of 2. What does that mean to do? Well, by definition, that's f of g of 2. So let's do the inside first. Let's calculate g of 2. The f just is going to stay out there. G of 2 means take 2 and plug it in the g function. So when I look at my g function, it's just x squared. I plug a 2 in there. That's 2 squared. All right? That's going to give me f of 4. Now, f of 4 means go to the f function and plug in 4. Well, that would be the square root of 4 plus 4, which would be the square root of 8. But we're not supposed to leave a radical unsimplified. We can rewrite the square root of 8 as a perfect square, right, times something else. We could write it as the square root of 4 times the square root of 2, which gives us 2 square root of 2. And that's how you would simplify the radical there. Problem number 5, very similar to problems 3 and 4, except we have different kinds of functions. So let's find f composite g first, which means I'm going to calculate f of g of x. Now, because I don't know what x is, what I need to do is I need to write the f function down with no x's. So 1 over x minus 2 is going to turn into 1 over parentheses minus 2. And then what goes in the parentheses is my entire g function. All right, so my entire g function is x plus 2. So that goes in those parentheses. Now after that, I just need to simplify. So it's going to give me 1 over x plus 2 minus 2. Plus 2 and minus 2 cancel each other out when I add like terms, and I get 1 over x. Now let's go backwards. G composite f. Okay, so G composite f of x is going to be g of f of x. Now again, because I don't know what x is, I'm going to start on the outside and write down my g function and put parentheses where the x is. So it's going to be parentheses plus 2. What goes in the parentheses? What's inside, which is the f function. Okay, so the f function is on the inside, and f is 1 over x minus 2. Now, simplifying this expression is a little more challenging because we need to add these like terms to these fractions together. And you might be thinking, that's not 2 fractions, but yeah, it is, right? That's 2 over 1. So to be able to add these, I need a common denominator. So I need to multiply this second fraction by x minus 2 over x minus 2. And that's going to result in 1 over x minus 2 still there, plus distribute, that's 2x minus 4 over x minus 2. Since they have a common denominator, write it with one fraction, 1 plus 2x minus 4 over x minus 2. Add like terms. Now the 2x I'm just going to bring across. 1 subtract 4 is minus 3 over x minus 2. And that is completely simplified. So a lot more work to do in G composite F than F composite G in this particular situation. All right, and then the last problem. G composite F of 2. Okay, so G composite F of 2. Now by definition, that's G of F of 2. So do the inside first. What is F of 2? Well, I take my 2 and I plug it into the F function. So that's going to be 1 over 2 minus 2. So that's going to be g of 1 over 0. And you're like, 1 over 0 is undefined, right? So we cannot do this. Turns out 2 is not in the domain of G composite F. So the answer is just undefined. Now if we continue our practice with F composite G and G composite F, here we go. F composite G, by now you've got this down. F composite G of X is F of G of X. Now again, if you don't know what X is, then what we need to do is substitute. So what do? We write the F function down without the X and use parentheses instead. So that's the square root of parentheses minus 2. Now what goes in there is your G function. So you're just plugging in your G function for every X in your F function. My G function is X squared plus 2. And then I just simplify what I have. So this is the square root of X squared plus 2 minus 2. Okay, well, the plus 2 and the minus 2 cancel out and get the square root of X squared. And all the square root of X squared is X. Now, actually, it's the absolute value of X because your answer for a square root is always a positive value. Don't worry. If you just give me X, I'm plenty happy, but there's a little bit more that goes into that thought. It kind of depends on the domain. But let's keep going. Okay, so the next one, we have G composite F of X. By definition, that's G of F of X. So what am I supposed to do? I'm supposed to plug in F of X for every X in the G function. So write down the G function with parentheses where the X belongs. And inside there is the F function. So inside, I'm going to put the F function, which is the square root of X minus 2. Now I keep simplifying. Look, this square root goes all the way across, which means I can cancel that square root and that square, and I get X minus 2 plus 2. All right, and then minus 2 and plus 2 cancel each other out to also get X. And again, don't worry about those absolute values. That's something I want you to get hung up with right now. Now, a little quick reminder, if you'll remember, when you get X for both of your values, when you calculate F composite G of X and G composite F of X, that means that G and F were inverses of each other. So that's something a little extra. It's from a different section, but you need to recognize that. If you get X for both of them, they're inverses. And then for part C, I ask you to calculate F composite G of negative 1. Now what that means is calculate F of G of negative 1. Now you could just plug negative 1 into F composite G, which is right here. If I plug negative 1 in for X, I get negative 1, right? Unless I have the absolute values around it, and that's where it gets a little bit weird. But if let's just do this calculation, okay? So this is going to give me F of, now what's G of negative 1? Well, I'll take negative 1 and I'll plug it into my G function. It's negative 1 squared plus 2, right? So that's F of, now negative 1 squared is 1 plus 2 is 3. All right, and then F of 3 is going to be the square root of 3 minus 2. And then 3 minus 2 is the square root of 1, which gives me 1. Now, remember we talked about that absolute value thing earlier? If I would have just said the square root of X squared is X without the absolute value, then I take negative 1 and plug it in there, and then I get negative 1. But see, those absolute values are required. Why? Because a square root is always positive. But if you do it this way, you're always going to get the right answer. Now for problem 7, I give you the two different graphs on one XY axis and ask you to find a lot of things. So F plus G of negative 3. Now by definition, that is F of negative 3 plus G of negative 3. Okay, so I need to find F of negative 3. And first of all, I need to find negative 3, right? Here is negative 3 on the x-axis. Now, F of negative 3 means I need to go to the F function, which is the blue one. And so I go up and meet the blue graph, and my answer is 4. So F of negative 3 is 4. plus, now g of negative 3, I need to go to the maroon function, and I go up there, and that y value is 1. And then 4 plus 1 gives me 5. So f of negative 3 plus g of negative 3 is 5. That's part A. Now part B, I'm asked to find f minus g of 0. So it's going to be f of 0 minus g of 0. So I need to go to my graph, and I need to find x equals 0, which is right here, and I need to do f of 0, which is the blue graph. So f of 0 is 2. My y value is 2 at 0. Now when I look at the g function, which is the maroon one, at 0, that answer is 1, and 2 minus 1 is 1. So f minus g of 0 is 1. Part C, I'm asked to find f times g of negative 2. Well, that's the same as finding f of negative 2 times g of negative 2. So I go back to my graph and I find negative 2, which is right here. And my f function is the blue one, so I go negative 2 up to my blue graph. That answer is 3. The g function is my red, so I go negative 2 up to the reddish graph, and that is 2. And we know 3 times 2 is 6. Part D asks you to find f divided by g of 2, which by definition is f of 2 divided by g of 2. Now f of 2, so first of all I have to find x equals 2. That's right over here. Now f of 2, remember your f is your blue graph, and my blue graph is negative 1 at 2, and my red graph, which is my g function, is positive 1 at 2. Negative 1 divided by positive 1 is negative 1. And then my last problem, problem E, I ask you to find g divided by f of 3, so that's g of 3 divided by f of 3. So g of 3, first of all I need to find x equals 3, which is right here. The g is the blue graph. G of 3 is negative 3. Now f of 3, remember f is I did that backwards. Let me back up. The g graph is the red one, right? The red graph at 3 is actually 0. And then the f is the blue graph at 3 is actually negative 3. And 0 divided by negative 3 is 0. Alright, so 8a, we're asked to find f composite g of negative 2. By definition, a can be written as f of g of negative 2. Doesn't matter if you write brackets or parentheses. I interchange what I do, but that means I need to first calculate g of negative 2. That's my first step. Okay, so it's going to be f of, now we need to go to our graph. The g graph is the red one. So I go over to negative 2 and I go to the red graph right there when I'm shading it in purple. See, the y value is also negative 2. So now I calculate f of negative 2. So I go to x is negative 2, just happens to be again, and I go to my f graph, which is the blue one, and my answer is right there on the line is 0. So f composite g of negative 2 is 0. Question B, f composite g of negative 4 is by definition f of g of negative 4. Okay, so I do again, just like before, I do the inside first. So that's going to give me f of, now g of negative 4 means I need to go to x equals negative 4 and I go to the g graph. The g graph is the red one. Well, in negative 4, my y value is 0. And then I need to calculate f of 0. So I go to x equals 0, which is right here in the middle, and then I go to my f function, which is blue, and I get an answer of 2. So you see that? When you compare these two, they seem a lot different because we got negative 2 as our answer when we plugged in negative 2 over here. But that won't usually happen, that these are the same value. First you go to negative 4, the inside. Again, you go to the g graph, which, reminder, is the red one. So I go over in negative 4, and then the answer right there is 0, that I've highlighted in green now. And then I don't worry about x equals -4 anymore. I go to x equals 0, which is right in the middle, and then I go meet my f graph, which is up here at 2. All right, example C. We have G composite f of -2. By definition, that's G of f of -2. So once again, I do the inside stuff first. I go over to x equals -2, and I go to the f function, which is the blue one, and I get 0 for my y value. And then I calculate G of 0, so I go to x equals 0, and I go to the G graph, which is the red one, and I get -4. One more time. Part D, G composite f of 0 by definition is G of f of 0. So I do the inside first and I find f of 0. Now f of 0 means first I go to x equals 0, which is right in the middle. And then I go to the f function, which is the blue one, and my answer is 2. Now that turns into my brand new x value for my g function. So I go over here to x equals 2, it's right there. But this time, because I'm looking at my g function, I go to the red graph. Well, y'all, there's where the arrow is, but that's where it crosses right there, and that y value is -6. So G composite f of 0 is -6.